MS University, Tirunelveli, Masters in Digital Communication and Computer
Anuja,
yeah, ma'am.
Sorry for the interruption. Sir, sorry for the interruption. Actually, I forgot to start the recording. So kindly, I request Anuja ma'am to once again start the session.
Okay, ma'am. Good evening, participants. On behalf of Vailtech Rangarajan, Dr. Shakuntala, R&D Institute of Science and Technology, we welcome you all for today's second day session to this Atal-sponsored FTP on artificial intelligence-driven 5G 6G networks. It gives me an immense pleasure to welcome today's speaker, Dr. Shajulin Benedict. Professor received his BE degree in Electronics and Communication Engineering from MS University, Tirunelveli, Masters in Digital Communication and Computer Network Engineering from Anna University, Chennai, and doctoral degree from the Department of Computer Engineering from Anna University. Professor did his postdoctoral degree from Institute for Informatics, Germany since 2009 to 2011. His research interest includes energy consumption analysis, reduction techniques, scalability solutions for exascale and cloud applications, blockchain analysis, and 5G networks. Professor has published more than 50 papers in reputed journals, 2 books, 24 book chapters, and 4 granted patents. He is an associate editor in IEEE Access and an editorial board in reputed journal. He served as a professor at Essex CCE Research Center of Anna University, Chennai, and a guest professor in TUM, Germany. Also, he serves as a director of AIC IIIT Kottayam for nourishing young entrepreneurs of India. Now, I request the professor to take over the session. So, please.
Yeah.
Yes.
Let me start the screen. Is this visible to you? Is it in shared mode or?
Yes, sir. Yes, sir. It's visible. Kindly put it in that slideshow mode, sir.
Okay. All right. I hope it's visible now, right? Is it visible now?
Yes, sir, visible, sir.
Yes, sir.
Yeah, okay. Yeah, first of all, let me thank the organizers, also the HOD ma'am for inviting me for this talk. Today, I will be covering the topic 5G, 6G for next generation IoT applications. Basically, I'll be focusing more towards IoT-based applications, Internet of Things based applications. So, yeah, basically, prior to this, I had some collaboration. Also, ongoing, we have one IoT cloud-based entrepreneurial flow. What I will be covering today, basically, it is more towards IoT topics, but I will try to combine the IoT application with respect to the communication medium called 5G. So initially, I will start with next generation IoT, then what are the trends that are there in IoT, 5G, 6G networks, also remote healthcare monitoring, one application will be covered. The intelligence relating to IoT while applying 5G, and the research directions of 5G will be covered in this talk. So if any issues in discussions, okay, you can just unmute. Organizers could unmute and say a few words, because I could not see the next screen. Okay, I am only seeing the presentation screen, so I will be continually talking. If something is it's not reachable or something, please send me a WhatsApp message immediately, so that I will be aware of that. You are unable to get the message properly. Right. So, Internet of Things is very interesting domain. Basically, it's more about future internet, right? We have to get long more number of devices connected. So in the past, we know that network was only provided to computers, then to mobile devices and so on, but not to things as such, right? But Internet of Things aims to provide the internet to not only uh, the computing devices, but also to things or objects. It could be like fan, lights, bulb, and so on. So trillions of sensors or digitized objects are expected to be connected in IoT world. So because of this, lots of knowledge are possible, and entrepreneurs therefore try to find some new opportunities. They try to develop some techniques, how to improve the products, new ideas, some innovations based on this future internet. So it's a kind of future internet technology, which means every devices are sending some information, and the knowledge solutions will be up in the market. IoT creates a kind of smarter world, actually, right? Human life will be boosted up in near future, and it is also expected like in 2050s, most of the robots will be assisting the human being. uh, the society will be more knowledge driven, right? A person who wants to get some information, immediately he gets the information, not because of the human involvement, but because of the things that are involved, right? The things that are connected, right? All connected things will start sending some information, uh, provide some information that will also the machines become more cognitive, and the expert systems will become more and more general in upcoming years. Obviously, devices, almost wherever you find, in airport, gyms, hospital, and so forth, wherever, right? All will connect each other, collaborate each other, what they have sensed, and suggest what they could be done in the future using this, information. Obviously, we could understand that the Internet of Things will deliver a very, very smart environment, right? Intelligent environment. While we think about intelligent environment, it could be done, it could be connected using several ways. One among is 5G, right? Today we are going to discuss how these devices are connected, how protocols play around to connect these devices, and what information will be delivered to the end users, right? So, for example, if someone wants to print a document, connected things will just start to begin the conversation. The smartphone and the printer will start to automatically decide what it has to do, and then printer will be printing automatically based on the informations, and the print will be ready. Maybe the robots, if some tray-based robots are there, that could bring the print back to you. So all these things can happen with the help of these IoT-enabled devices. So can 5G support this? That's the main topic of discussion that we will be covering in this particular talk. Yeah, let us talk about this keyword called next generation IoT systems. So when we say about next generation IoT system, currently you could see a lot of IoT based solutions in the market, right? Many IoT solutions are there. For example, agriculture based solutions, logistic based solutions, many solutions are available. In the future, you can expect some devices that will get the support of not only cloud but also edge. Right? We will be talking about how this combination of cloud, edge, and fog could be more important or will play a major role in IoT-based systems. So 5G is trying to support this next generation IoT-based systems. 5G is therefore trying to bring more edge-based intelligence, okay, than the centralized cloud-based solutions, which was the common scenario in the old, traditional approaches. Not very old, but still, traditional approaches. So 5G-enabled IoT systems is going to create a new wave, right? It's going to create a new wave in majority of the IoT applications that we could see at present. Like, for example, remote monitoring. One among example we could see in today's talk, visual inspection, right? Visually, you can see through glasses, or you see what's happening in the remote site. You can visually inspect what is happening on. You can perform some sort of augmented reality based solutions, right? So IoT in the next generations, when we call it as next generation IoT system, the data what is sensed from the sensor nodes are not just transported to the cloud. It will happen that, that most of the processing happens in edge, probably some in fog, and then goes to the cloud. And the network that is covering them, right? Network that are binding them could be of many protocols. One among is 5G. Also, you can see some applications in smart agriculture and logistics. So let us talk how this or what this IoT is performing, or how it is performing in the market, right? What kind of trend you could observe in the market of IoT. So you can see here, like now, about around 1 lakh patents have been filed, and this was taken in 2022. It's still, you could observe something near to here, right? So patent shows that innovations, right? IoT, with this keyword search as IoT, I could see this many number of patents, and it's constantly growing, right? It's constantly growing. This shows that the innovation is constantly increasing, right? A new product, new development is always upcoming one in IoT field. And you can also see that a lot of investors are there, right? Lot of investors. The market shows that around 1.5 trillion IoT revenue will be appearing in 2030s, right? This happens because several domains are well connected, right? You can see it showed the importance in agri, retail, healthcare, automotive, transport, logistics, manufacturing, and so on. So in all these IoT based systems, 5G technology is really applicable, right? um, Even the research and markets shows that $169.39 billion will be the trend when you reach around the 2030s, right? And you can also see that in different fields, right? Like smart city, connected industries, connected building, right? Then connected car and so on. So every places you can observe that um, the the trend will be very, very high. And you can see that major players of these technologies, IoT, comes from cloud-based systems like Microsoft Azure, Google Cloud, Amazon, right? So these are all major players for cloud, actually, right? So the cloud players have provided solutions for IoT, and in IoT you can still have the connectivity with 5G, right? So that's what we are going to see. So you can see that a lot of platforms, emerging platforms in IoT field are coming from cloud backgrounds. And all these cloud backgrounds, Amazon, or Google Cloud or Microsoft Azure are having 5G support. You can see here, like Microsoft Azure, they have developed Azure's private 5G core, right? And they have deployed or they are willing to deploy them uh, through some solutions, right? Google Cloud is also having solutions for 5G. So they have created a cloud-based 5G network. And also you can see Amazon. Amazon, they have AWS 5G, private 5G network, right? So what I wish to convey here is most of the cloud players, right? They have provided support to IoT, and in IoT you have so many communication systems. Among that, they have given some prior importance to 5G also, right? So this shows that the key players are having some affinity towards this 5G networks or creating such 5G based solutions, right? So before I proceed further to 5G, real 5G technology and so on, let me also talk a little bit about different IoT systems or subdomains of IoT systems, because 5G could be applied in most of the IoT based solutions, right? So let's understand how this IoT could be categorized. One is industrial IoT, second one is consumer IoT, third social IoT, semantic IoT, as well as productization IoT. Industrial IoT means the sensor network which is focused on industries, right? Like you could see um, a topic like Industry 4.0, right? Which shows the revolution with the fourth revolution, right? So this means you are applying embedded intelligence and network connectivity of IoT, typically 5G, okay, to improve the systems and to improve the industrial process, right? Say, for example, manufacturing car, right? If in a manufacturing car plant, the machines are communicating to each other, and these machines are talking to each other using 5G networks, then this is falling under the category of industrial IoT. 3D printing companies can utilize 5G systems to set up automatic printing processes. Manufacturing sector could do that. So Industry 4.0 is a fourth revolution basically, and people call Industry 4.0 in as a separate term, and it is predominantly called as Industry 4.0 in Germany. And the same term is called as industrial internet in the USA. So what's this Industry 4.0? It's again IoT, right? Internet of Things. Internet of Things that are applied for industries. So why we need to apply to industries? Because we need to get a good industrial revolution, right? You need to improve the process of industries. And this comes as fourth generation with the involvement of industries. The first three revolutions, if you see, the first revolution is due to the power engines, right? Because of the development of power engines, they revolutionized, right? They were they were able to minimize the manpower. The second edition, you can see it's because the electrical engine as well as power systems like belt conveyors. Because of this, also the industrial process improved. Third revolution was because of electronics as well as IT-based programmable controllers. So, but now in fourth revolution, that is when they call it as Industry 4.0, because Internet of Things play a major role. Right. So why this was brought? Because Siemens and some companies, they sat together, tried to understand what are the difficulties of the industry processes, and then they tried to introduce this the Internet of Things concept, and found that you can automate the processes. Some of the use cases, if you see, like predictive maintenance, right? Predictive maintenance is somewhere like you forecast saying that some sort of maintenance is required in some machines, right? So imagine that you have three machines, and one machine is producing some sort of noise. Okay, you could have some sensor here, and all machines could have sensors to detect the sound of that machine, right? And if some wear and tears anomaly is detected, right? So immediately the machine could send the signal to appropriate process, which could order the repairing part, or it could suggest some predictions there, right? So some prevention setup and so on. So predictive maintenance provides one way of handling the process, industrial process. Supply chain management, even like car manufacturing, or let us say your car is having tires which needs to be replaced, but you might forget to do that tire repair, or um, automatically informing the workshop saying that you need to replace the tire. You will not do that. But if a sensor is attached to that, right, then you could your sensors could, or the sensor node could send the signals to the workshop authorities, and the workshop, not directly to the people, but to the machine over there, or some service that are staying there, and then it can automatically order the appropriate raw materials, and it can make a notification to your mobile phone saying that now you need to go for workshop, right? So such kind of processes automate the industrial process, right? That's the advantage of Internet of Things. So typically, automated manufacturing is also possible. Machines are communicating with other machines, and because of that, you are able to get bigger advantage out of that, right? So customers are benefited because they can get something in affordable price. If you are in a last minute going for tire repair because your tire bursted and so on, you have no choice. You will have to pay whatever he has informed, right? Whatever the workshop person has informed. But if the sensor automatically identified all these things and it has communicated to the system, or some other workshop people, if one workshop is have forecasting some higher price, it can find the competitive workshop, and you can get the message, right? This, you can go to this particular workshop. So customers will be benefited out of that. Also, the industries are benefited because not only one car, you can find crores of tens of thousands of cars everywhere with similar kind of manufacturing requirement. So then the industries could make a mass production, like tire company could make a mass production, understanding the demand that was raised from all these cars, repaired cars. So these are all the important processes that happens in industries. Similarly, consumer IoT, like wearables, gadgets, portables, implantables, handhelds, the consoles, and so on. This, whatever you wear, these are all, if they are identifiable and if they are having their own IP addresses, which means they are Internet of Things, right? So these things can also be more productive for you, right? For example, a writer, he wants to write certain number of pages, but a wearable which is attached to you could send some information by automatically collecting the information and giving you the message, right? Say for example, some of the smartwatches, right? So these smartwatches, some smartwatches are voice assistant ones. So you could just talk to them, and then that will give you the message while you are writing, right? So you are getting all what you need during the process of doing things, right? It's making you more productive, right? But there are challenges, but because some devices will not be compatible enough to the services that are attached to you, right? And all this connectivity with IoT systems can be more productive if we go for 5G systems. That's what we will see in the next part of the talk. So you also have social IoT, semantic IoT, as well as productization IoT. Social IoT means it's a subdomain of IoT which talks about sensing the information from social media sites. Okay, there are so many social media sites like Facebook, Google Plus, LinkedIn, and so on. There is a requirement of some sensory information or sensory services which could collect or sense the inferencing information from the system, right? From your social media, your friends' social media, from friends' social media sites, and so on, which as a human you will not find it easy for doing things. So some of the examples, like you want to extract likes, dislikes, updates, and interactions of different connected people. So you want to find the friends of friends of friends of friends person, right, in that circle, who may be somewhere in the whole world, right? So you could get that with the help of such social IoT systems. In fact, all these processes could be improved with the help of IoT and 5G systems. Semantic IoT is more like tailored ones, which is specific to certain people, certain context, right? Typically, like ontology techniques will be added there. Productization IoT means you design your own designs based on the feedbacks and systems that are available. So it's like more towards producing or manufacturing things based on the feedbacks and the solutions that are combined with some crowd systems. When you talk about consumer IoT, you can also think about healthcare applications, because healthcare is one of the major player, basically, right? If you think about the healthcare, for example, fall detection, identification, right? After an age of say 80 years old, there is a high chance that people fall down, and because of that they get hip problems, right? This hip problem uh, could make a person bedridden and he could not do anything afterwards, right? So, but there are textiles that develop some truss. It will automatically enable the actuation based on the based on identifying whether the person is going to fall down. So based on sensing that things, right? Similarly, for diabetic patients as well as cancer patients or stroke patients, you may need to make some decisions at the edge itself that could be done there. Activity checking, right? Physical activity checking. Some textiles are there that can warm the temperature automatically, right? Because it's very common that when you go out, sometimes it may be at 10 degree, and after you do little jogging, your body temperature will slightly rise, and at some point of time you may feel that you don't want sweater or something, but instead of having discomfort, you could have some devices, sensor based devices in textile itself, which can automatically enable the heating, right, which keeps the temperature, body temperature, always to 25 degree or 22 degree based on whatever you have set. Wearable devices, therefore, are more helpful in such healthcare applications, also in education sector. Why I want to talk about all these, these applications, 5G also helps in such IoT-based systems. We will be covering the topic in the upcoming slides. So education sector, like for example, you want to have foreign language translation. You are in some location where you doesn't know the language. For example, you went to some North India, some parts of North India, right? You don't know Hindi, right? Then with the help of this device, you you can just show it to the screen or to the board, and it can automatically translate them, and you can get the right message in your language, right? Or connected smart classrooms could be done. Collaborative learning is also one of the approach that people follow, where multiple learners all over the world can sit here and there and suggest cues, answering cues, and so on. So all these are different solutions that you can think about. Also, indirectly, if you see, like you can also have IoT-based systems for attendance monitoring, learning from home. Similarly, personalized learning, like you may be interested in some particular topic, like for example 5G. Uh, then you can provide that hint to the learning system. So this particular learning system can automatically find all apt relevant information time to time and give reminders and messages, so that you will keep updated about the current trends, news, and so on. So this becomes like personalized learning. Or some particular news topic, like you can have reminders stating what happened in this particular country, right? Every now and then you will get some reminders and messages. So sensing happens so that improves the learning processes for a personal person. Machine to machine applications like smart energy, smart healthcare, right? Smart home security, smart cargo handling, smart traffic management, smart inventory and management, smart cash payment, smart tracking, smart displays, smart manufacturing, smart asset management, smart retailing. These are all applications where you can think of some machines, right? It's not people, machine talking to another machine. Okay, when you talk, you can apply 5G. You can also apply other protocols, but I'm trying to talk about 5G. But I need to inform you that all these are like kind of IoT. Okay, Internet of Things, some things, not like a machine, not like a computer, but they are things, small things, or sometimes bigger things, right? These things are directly communicating to the next thing. As like in healthcare sector, the patient's sensors will talk to the nearest device, maybe your mobile phone, right? So the mobile phone can take some decisions on your absence, right? So you can send the notifications or whatever to the appropriate listening services, and then maybe it could be from hospitals, and then the hospital machine, not hospital authority, hospital machine will give some messages and communications, right? So that's these are all different applications. Smart tracking, smart payment, smart asset management, all are machine to machine applications. So I have told that Internet of Things is a important trend where 5G could be applied. So that's why we are now learning little about IoT. Let's try to see what's really there in such IoT systems, right? So in any IoT system, you will have sensors, actuators, and in between you have networks. Okay, so network to devices. So network to devices are some devices like cloud, edge, fog. So these are devices which are performing some actions or performing some computation and things like that. Sensors are just sensing what has to be done, and actuators are doing some actions based on that. So what kind of sensors are there? There can be several sensors, something like camera sensors, smoke detection sensors, obstacle detection sensors, right? So in principle, a device which measures a physical property is termed a sensor. Okay, these sensors can be of different shapes. It can have different properties, Like it can measure chemical, it can measure mechanical, it can measure electrical, it can measure electronic or light. And these sensors are finally converting it into some electrical signal so that you can do some processing. So it has to be sensitive to some measurable property. Okay. What kind of measurable properties are there? Like temperature is one of the measurable property, right? Light is one of the measurable property. Likewise, it has to measure the properties, measurable properties. And these measurable properties, these sensors should not influence the measured property, right? When you talk about sensors, resolution is one of the important keyword that we normally see. Like for example, a camera sensor, that the resolution. We talk about resolution, like how accurate you can measure, right? Some sensors will have very less resolution. Some sensors will have higher resolution, and depending on what kind of output you get, what kind of output, whether it is continuous output or whether it is a kind of digital output, whether it is ones and zeros or whether it is having some predefined values like 0, 5, 10, right? So predefined values. So depending on what kind of output it could produce, it is classified into analog as well as digital sensors based on the type of data. Okay, it's like, for example, sometimes the sensors can provide some directions. Some examples are camera, right? Also sound sensor. You can get the direction, like where from you're getting the signal, or it is only scalar. It can only measure the amplitude or some magnitude of that sensing. So that is scalar type. So here you can see some list of sensors, because all these sensors may have to get connected to the network. Right? Network consists of compute nodes. Okay, and all these compute nodes are connected in one way or the other using some networking protocols like 5G. Sensors such as light sensor, touch sensor, humidity sensor, temperature sensor, force sensor, water flow sensor, position sensor, speed sensor, soil moisture sensor, ultrasonic sensor, chemical sensor. Right? So sensors are of several types, and IoT is based on these sensors. So you can have different error formulas, right? Like sometimes sensitivity will have errors because the reality may be different, but what value you get from the sensors may be different. You may get offset errors or biased errors, and some sort of drift errors. This means like because of the malformation of sensors, always you will get some modified value, right? Temperature sensor, if it is always having a difference of 1 degree, then it's a kind of drift sensor. Sorry, drift. It's termed as drift, right? Sometimes you get a kind of random deviation. A sensor is for this time it shows 32 degrees centigrade, but next time if you see it's only 31 degrees centigrade, but actually it is 32 degrees centigrade. Then it's kind of noise. It's termed as noise. Hysteresis error is like a error which accumulated after long period of time, right? One value accumulated, and the sensor will capture, or historically it is creating the errors, right? Time to time it is showing varying errors, but gradually it is having differences. So that's sensors. Actuators are actions, the devices that perform actions. Actuator is a component that moves or controls the mechanism of a system, right? There are of two types, linear as well as rotary actuators. You can classify the actuators into several types, right? Like hydraulic actuators, pneumatic actuators, electric actuators, thermal or magnetic actuators, mechanical actuators. So hydraulic actuators means the actuators that perform some mechanical action because of hydraulic power. If it is performing based on air, then we call it as pneumatic actuator. If the actions are performed because of electric signals, most of the IoT systems will have these electric actuators. Or if it is providing some action because of some thermal thermal values, then it is called as thermal actuator. Likewise, you have several actuators. Fine. So what I covered so far is what is an IoT. So in very short form, an IoT is a system. Internet of Things is a system which is a future internet. Okay, where the things are connected each other. Things are connected each other. All things, right? So the things include sensors, actuators, and these sensors and actuators are connected each other using some connected devices or some compute network to nodes, right? So how these connections are happening, right? What are the different connection related protocols? How your sensors, right? Let us say these are sensors and some other sensors and some devices are connected, right? You can connect it with several protocols. One protocol is 5G. Got it. So let us talk about different protocols. I will quickly go through different protocols. In fact, there are several connection protocols. Okay, we are just talking about where is this? Here, we are just talking about 5G and 6G, right? But an Internet of Things can have several connection protocol or standards. At least we shall look into these protocols. Okay, and then we will be covering this 5G and 6G, which will be more interesting for us to understand the differences, how why we need to connect it with the different protocols, right? So IEEE 802.15.4 is a typical standard that is very commonly used in IoT systems. It's basically, like PAN, personal area network systems. Typically, it has only 10-meter, coverage. So this typically, cannot fit to many of the IoT applications, but you can you use IoT in IoT systems. We normally use this very low range and low power because we know sensors are often battery operated, right? They are often battery operated. So if it is battery operated, we should think about battery lifetime. So if you are giving more power, right? If it is then obviously the battery operated sensors could not handle them, right? So in normal IoT systems, IEEE 802.15.4 standard is followed. Okay, and this is operating in 2.4 gigahertz, all right, uh, which is meant for ISM, right? Industrial, scientific, and medical radio band. This band is not applicable in 5G. Okay, 5G is a different connection protocol. But I wanted to introduce you different protocols or different standards that are available in IoT world, right? Only then we will understand that 5G is also possible and what are the pros and cons of applying 5G. Of course, in IoT systems, because of very tiny devices and the systems, it might not fit to 5G, might not fit to many of the applications, but it fits to some of the applications. We need to understand what are those type of applications. It's according to the standard, it classify the devices, IoT sensor-based devices into two broad categories, like fully functional devices and reduced functional devices. Fully functional means you can have all sort of routing algorithms can be there. Uh, it will support basically all protocols in the networking stack. Okay, because typically these are full functional devices are often power sourced. Okay, they are not battery sourced, power sourced. But reduced functional devices are the categories where you get battery operated ones. So some sensors they cannot really get the power because in a machine, let us say there is a machine. This is typically very remotely located, and if you want to place the sensor here, right, it is not always possible to reach here, right? So you may have some small battery, long-lived battery, right? You may have long-lived battery. You may place that battery, and the sensors will be very small also. And here maybe you are having the power grid and power devices. So this sensor may have to communicate with this power source devices. So then this kind of device is reduced functional device. So that is one standard, right? The other one is Zigbee. So Zigbee is very popular in IoT systems, right? Most of the smart home devices often use Zigbee devices. It's also a connection-based protocol. Okay, that's used for IoT-based systems. The attraction of this Zigbee protocol is it can create mesh networks very easily. Okay, just you need to plug in this Digi Zigbee device, and you can simply connect as many, at least 5, 6 sensor nodes could be connected simply and create a mesh network. This Zigbee protocol is basically, very good for enabling mesh network, and it is basically formed using the Zigbee Alliance, right? Almost most of the protocols, whatever we see, are having some governing bodies that will design things like that. The additional features, of that, this particular Zigbee is somewhat deviating from IP versions or IP protocols, like TCP/IP protocols. Okay, we know the TCP/IP standard. TCP/IP standard has several layers, right? Like physical layer, data link layer, um, network layer, right? Then the application layer or transport layer, application layer. So, but this protocol stack is modified basically in Zigbee protocol, right? The idea why they brought Zigbee is to bring more connectivity and therefore they try to change the protocol, the entire TCP/IP protocol stack. So and they try to bring this mesh kind of network. Okay, so the important features of Zigbee is authentication is very good here. Um, Data forwarding and so on are very easy because of mesh networks. Similar connectivity, you just want to plug in, and the protocol itself has some features to automatically make the connections and create the mesh and communicate each other, right? Since the bottom two layers are same, okay, Zigbee has same protocols in the bottom two layers, that is the physical layer and the data link layer. These two layers, okay, are the same as like what we have seen in IEEE 802.15.4 standard. So, what all things we could see from IEEE 802.15.4 standard devices is also applicable to Zigbee, but the difference starts from the upper layer. Okay, there is no real transport layer here in Zigbee protocol. And it is claimed to have more battery life, low latency. Okay, it supports direct circuit spectrum, so it travels as like noise. And because of these many features, the Zigbee protocol was very popular in many of the smart home related applications. You can see here now the protocol stack is differing, right? Network layer is there, but there is no transport layer, right? If you take TCP/IP standard, you will have a transport layer, but here there is no transport layer. Instead of transport layer, Zigbee brought a new layer, so it is not following the normal standard. So therefore, Zigbee protocol is not compatible with many of the normal TCP/IP standard-based systems. So it is not following the normal standards, right? This is one important distinction which kept Zigbee quite away from normal systems, normal network systems, because we all know why we went for standards, right? TCP/IP standard or ASOS standard. We went for that because we need to easily communicate with the other devices. But in this case, it is not possible, right? So Zigbee-based devices are suitable for only Zigbee-based devices. So a proprietary falling under the Zigbee Alliance design the devices, and they can communicate only with those devices, right? So it is not much well taken, right? Um, Although they attempt to bring good support by creating endpoints and you know, uh, connecting multiple devices by creating mesh and routing and routing discovery and so on, right? Direct addressing was possible. All best features were added uh, exclusively for IoT based systems, right? Considering energy consideration, energy, battery lifetime, and so on, only considering those things, they designed this protocol stack. But because it is not following TCP/IP standard, it was not compatible with the other devices, right? Um, in this Zigbee, they had coordinators, right? Also routers and end devices. So they classified the devices that are following this Zigbee into these categories. So coordinator will coordinate the creation of networks. Then separate router was there, which was capable to relay the messages between the nodes. And end devices are typically like sensor nodes, which they call it as Zigbee end device, which will do the normal sensing or actuation and so on like that, right? So Zigbee primarily has device objects, and this is a part of a service that is hosted in Zigbee based devices. It performs many services, including service discovery or coordinating with other devices to establish the network, creating some management for security, network management, binding management, and so on, right? Uh, Endpoints were also created, and the the layer application application sub layer was responsible to do all these things. So IEEE 802. This particular standard was a very core thing for Zigbee, right? We didn't talk about the 5G, but we are talking about these connectivity-based protocols because sensors and actuators, sensors want to perform some actions, but it has to do through connected devices, right? These connected devices or compute nodes, typically cloud, fog, or edge, they want to perform some intelligence and they want to make some action. That's what we are trying to discuss. 6LoWPAN is another protocol, another communication protocol, which is IPv6 based. Okay, from the name itself, you can understand it is IPv6 based, and it is talking about low power as well as low power. Okay, low power wireless personal area network, right? Personal area network means obviously it is following this IEEE 802.15.4 because that is the standard for PAN networks. It's purely having this IPv6 approach, and mostly wireless devices use them. right? It is focusing on low power devices. This 6LoWPAN is targeting energy efficiency as like Zigbee. Okay, but Zigbee failed because even though it had energy efficiency, it was not successful. Why? Because the protocol didn't follow the TCP/IP stack, right? But in 6LoWPAN, it is following normal TCP/IP standard or ISO standard. It is following that, and still it is able to bring energy efficiency, not to the extent of Zigbee, but to the reasonably okay approach, right? So essentially, 6LoWPAN products have reached the competition. Okay, and immediately Zigbee, what they did, Zigbee Alliance, they even framed the Zigbee IP. Okay, so they brought brought some protocol stack such that it was also energy efficient, and with little compensation, they brought the entire protocols that becomes compatible with normal TCP/IP standard-based systems. But the 6LoWPAN took a better shape at that time, right? Because of the seamless integration. Okay, it can integrate very well with normal IP-based systems. So you can see here the difference of 6LoWPAN and Zigbee when compared to ISO model, right? So here you can see there is no transport layer. Because there is no transport layer, it is not following the normal TCP/IP standard or ISO standard. Since they are not following some standard, networking standard, it is not in the market. But people wanted Zigbee for smart home and so on, because it is extremely energy efficient. Okay, it's extremely energy efficient. So battery lifetime is good there, right? So the other one, I am just shrinking all the topics together, because IoT with 5G based systems, or like one semester course which I handled in Technical University Munich, Germany. Okay, so I'm just shrinking everything to very, very minimal version of what was, right? So I hope I'm still alive. Can anyone just to say a few words? Am I audible? Am I audible? I did not get any message actually. Any organizers? I could not see the uh, screen actually. I hope it's audible, right? If not, please send me a message, okay, through WhatsApp, because the presentation screen is entirely different from what you can see here. Right. Fine. Let me continue if it's still working. Next protocol is Wi-Fi. Right. Wi-Fi communication protocol is basically wireless fidelity. It's a communication protocol which is very popularly used in systems, right? It attempts to provide the in-building broadband coverage, right? As like a normal broadband, no, you get Wi-Fi. Wi-Fi, it provides a very good connectivity, um, and very good bandwidth too. It supports basically fixed channel bandwidth, right? Wi-Fi is operated in wireless systems. And nowadays you can see that wireless systems are having Wi-Fi 6 and 6E. These are very recent standards that even targeted power efficiency as well as high speed. It supports base station based and ad hoc connections, because a tower or access point will be there, right? And let me put it like this: access point, and this access point will connect multiple sensors or actuators, right? Mobile phones, right, can also get Wi-Fi connectivity. Your laptop, your any electronic gadgets these days can get Wi-Fi connectivity, provided one access point is there, right? So Wi-Fi 6 is nowadays very recent one, right? It falls under this 802.11ax standard, which is released in 2019. Uh, but most of your or our normal access points are compatible with, I mean, it is only having Wi-Fi 5, right? Very recent devices will have Wi-Fi 6. Just the performance is high in Wi-Fi 6. Normally, if many devices are connected to Wi-Fi network, typically it can slow down. But in Wi-Fi 6, it is having some better connectivity. So here I have given the comparison between Wi-Fi 5 as well as Wi-Fi 6. This is the new one, and Wi-Fi 5 is presently, I would say most of the organizations are using Wi-Fi 5, right? The speed here is 3.5 gigahertz, gigabit per second. But in Wi-Fi 6, you can expect around 10 gigabit per second. Connection to internet is, each device gets internet one at a time. But here, you can get multiple devices and internet, right? Typically here it will be like time shared one, but in Wi-Fi 6, since it is following orthogonal frequency division multiplexing access technique, many users simultaneously can get internet, right? In some cases, uh, beamforming, that is, you unidirectionally send the signals, right, the beams to some devices, which is possible with Wi-Fi 6, right? And also, battery utilization is also very good here in Wi-Fi 6, because it is not expecting the device to always, a kind of target wake-up time. So typically, if a sensor or a device, if it wants to go to sleep, it can sleep, because most of the time sensor should sleep, because it has to it has to maintain a better battery lifetime, right? The other one is LoRaWAN. It is also a protocol which provides wide area network. From the name itself, you can understand. Wide area network means it will have long range, long range. So it is also providing low power and long range, and it is having WAN. We know LAN is local area network. It is limited to some organizational jurisdiction, right? But WAN, LoRaWAN is providing WAN technology, right? So you can typically reach around 10 kilometer, okay, 10 kilometer in rural areas. So just a small device, and the battery consumption is also very low, right? You can reach or you can send the sensor data to 10 kilometers. Okay, so imagine that your agricultural farm is very, very far away, and these sensors, small sensors, okay, battery operated ones, so battery will be connected here, and they can, if they are following this LoRaWAN technology, they can reach the gateway, okay, gateway, and from gateway to the cloud or any computational node, which can happen like 10 kilometers, right? So LoRaWAN technology is one of the protocol, right? One connection protocol. We are talking now about connection protocols, and in urban areas it is limited, okay, to 500 meters, or theoretical distance could be like 700 meters. But in urban areas, it can really reach around 10 kilometers, according to theoretical values, right? How is this happening is, it is compensating with the bandwidth. Okay, if you take the x-axis, y-axis curve, in Wi-Fi and 4G, 5G systems, you have a very high bandwidth. Okay, so you can easily watch video, movies, and so on with Wi-Fi or 5G, 4G technologies. But you cannot do that with LoRaWAN, or you cannot do that much with Bluetooth, right? Because bandwidth is less, right? But talking about the coverage, distance, LoRaWAN can reach 10 kilometers, right? But the other technologies are limited in range, right? So that's what we want to understand here, and they are licensed and they have to follow different frequency setup. Okay, so gateways are available. You can use them, right? LoRaWAN technologies are very popularly used in some applications like smart metering, parking systems, waste management, where smart bins will be there and it will just send one message, full or not full, right? Only very small data. So the sensor could stay long with its battery, because the bandwidth what it is going to utilize is very less, and it can reach long distance. Right. Some of the gateways are also shown in the map actually. Yeah. Coming to the 5G, it's very important, right? The trends and underlying. So our core topic now relates on 5G as well 6G. Basically, we want to discuss IoT-based systems uh, in IoT-based applications, right? Next generation IoT-based applications. There are so many ways of connecting sensors, right? We talked about several protocols and several ways. We want to understand that now IoT applications are very, very core things there. The last protocol which we are going to cover is 5G and 6G. It is relating to mobile networks. Okay, mobile, like mobile tower or mobile systems. Wi-Fi is not mobile, right? It is like a local area network, right? You will have to use them just within one location. But 5G technology is following the mobile networks generation, right? Mobile systems or mobile devices, mostly your phone systems, right? They had several generations. Through this mobile networks, towers, we are able to send data, right? So 5G is the fifth generation of such wireless systems. IoT systems can also use 5G systems. Nowadays, 5G services are available in India in some select places, not all. Okay, Chennai, Bangalore, Hyderabad, and some places they have 5G enabled systems. But in 2023, 5G will be available in all parts of India. We have to thank some of the leading players here, especially Reliance. Right, Reliance is playing a major role, dedicatedly helping to connect, every part, Reliance Geo basically, right? And we should also try to see the trend with the keyword 5G. See, it's very steep growth. Okay, uh, very peak improvement. And there are so many good companies who have developed a lot of innovations. Qualcomm, Samsung, Intel, right? Huawei from China, Oppo Research from China, right? So many companies are developing a lot of innovations, lot of devices based on 5G. many sensor-based devices are also developed using 5G technology, right? Qualcomm predicted that in 2035, okay, lot of economic growth will happen because of 5G. It is also predicting that the 5G could support around 22.8 million jobs. All are recorded in the news actually. Global Mobile Suppliers Association research also predicted that there will around 481 operators. Mobile operators means like BSNL, right? Reliance, Geo, and so on. Likewise, in global world, our world, around 481 leading mobile operators have invested in 5G. If someone is pumping money, there are a lot of growth, right? So that's the reason a lot of job opportunities are expected. And in 2025, it is expected that 1.7 billion subscribers will be there. Our world population is 8 billion, right? It's somewhere like 1.7 billion, around 20% or around that will be using this 5G system, right? So it's worth investing or taking time to understand how 5G will be applicable not only in your normal mobile systems, in sensor world. You can see like China is leading, and US is following that, and you can see majority of the countries are keeping up to get into the utilization of 5G. So what are the service objectives basically? First important objective is high speed. Okay, so in sensor world, lot of sensors, actuators, you have some connected devices. All these connected devices are connected. Sensors are connected, devices are connected. All these devices are connected, right? Can you connect it using 5G? If you can connect it with 5G, can you provide high speed, right? As similar to Wi-Fi, can you provide a high speed of 10 gigabit per second? 5G is able to provide. That is the goal, right? If a machine wants to communicate to the other machine, a hospital, one machine or sensor machine or a robot kind of machine wants to send the captured image directly to the next machine to make some sort of processing. Like sensor from here is communicating to the next sensor, and the next sensor is communicating. Sensor is communicating to the device, and device is communicating to the actuator. Next sensor is communicating, and it is communicating to the next actuator. All right. So action is sensing is performing, action is performing, and can you make it fast, right? High speed with low latency, right? And can these machines do it fast? These are the three major goals of this 5G, right? If you see the growth of this 5G, first generation is just 2.4 kilobit per second. Second generation is 64 kilobit per second. Now we are 5G means it is mobile network, mobile systems, right? Mobile tower, base stations, and so on. That is the network. In that network, can we provide high speed? Can you provide 10 gigabit per second speed? That is the concept what we can see here in 5G, right? So first generation was just 2.4 kilobit per second. You cannot do anything useful there, right? 64 kilobit per second also cannot do anything. 2 Mbps, okay, to some extent. Nowadays, everywhere you can see fourth generation, which is having around 1 gigabit per second. 1 gigabit per second, 100 Mbps typically, 100 to 300, 400 Mbps are possible with 4G, right? Theoretically, 1 Gbps. You are able to watch videos, listen to online classes. But in 5G, see here the difference, 10 gigabit per second. It's very, very fast, right? So you can see, you can expect a very high speed system. Streaming of video will be very fast. In within 1 second, you can get the internet, the videos downloaded and watched, revised. Everything can be done. Lot of applications you can do with the help of 5G connections, right? 1G is not at all a discussion nowadays. It's because analog and it is not at all reliable. 2G edge, okay. People in some places you still have edge connection, but this is also not not at all valuable these days. 3G, we are in most places you get this 3.75 generations H plus, right? H plus symbol you can see in mobile phones, right? Which is typically having around 42 megabit per second speed. And 4G and 5G, we are actually waiting for 5G. And in some cities, you are experiencing 5G, right? But very limited. In many places, you have 4G. We should also thank the BSNL because BSNL is also offering 4G almost in many rural places too, right? Not all places, but many rural places you can see 4G connections, right? So because of that, you can get HD TV, high definition TV, video gaming is possible, conferencing is possible, online classes. We can utilize many video based applications, but it is having some limitation. What is that limitation? Latency. Okay, latency with video is adjustable, but you cannot utilize it for some real world applications, real time applications. Like for example, a doctor performing some operation, he cannot do it with 4G. Okay, he cannot do it with 4G because if you want something at real time, latency becomes a problem, right? You need some kind of ultra low latency, which is what 5G is trying to provide. Got it? And 6G is still on research. You can expect 6G in 2035 or something like that. Okay, 5G offers very low network latency, which means the end-to-end communication delay is very less. Obviously, in autonomous vehicles or autonomous vehicle-based applications, 5G is very, very important, right? So a lot of sensors in vehicles. What kind of sensors do you expect in car? You will have detection like distance, some obstacle detection sensors will be there. You should also detect the passengers. You should detect probably the lane, right? The road. You should detect the road. So a lot of sensors are detecting all these things. And what are the actuators there? Brakes are actuators, right? Horn is another actuator. Some seat belt comfort is another actuator. Likewise, so many actuators are there. The connection between the sensor and actuator through the networked device or connected devices, if they are happening through 5G, then we call it like IoT system, next generation IoT system with 5G enabled approach, right? So intelligent sensors will have to detect such obstacles, and immediately it has to perform some action. If you apply 4G there, the latency will be very low. Latency will be high. So what would happen is, the sensor will send the command to the computing node. Computing node will decide that you need to perform some brake or perform action like brake. It will not do it. So there is a possibility for accident, right? So at real time, if you want to perform some action, right, and still this is a kind of ambitious the car, right? Ambitious car, autonomous vehicle, right? No drivers there. He's just watching movie there, right? And still braking and everything should function. So 5G systems can perform well, right? It is expected that less than 1 millisecond no, latency is experienced in 5G, or almost nil millisecond, or nil latency, right? So talking about the spectrum, it has three different bands: high band, mid band, as well as low band. High band means only 5G is kind of a true 5G setup, very high band. Okay, mid band, there are two categories: mid band 1, mid band 2, and low band, it is having the capability to reach even smaller distances, or small long distances, right? So you can, here I have shown the classification. Like, the more you go for high band, you can experience the true 5G. The more you are in low band, you will not experience the real 5G, but still your mobile or your device, sensor device or actuator device will show that you are having 5G, right? What are this band? Low band is having something like 600 to 850 megahertz. Mid band is having something around 2.5 to 4.2 gigahertz. And here it is something around 25 to 39 gigahertz. The coverage in mid band is like 10 to 30 kilometers. Low band, it is hundreds of square miles. But this one is very, very less, 10 to 50 meters, right? So this kind of band is also called as millimeter wave spectra. Okay. Uh, Very interesting part here. You can see that high band, because it is very high band, it can only reach very less distance. It will be obstructed. The obstructors like buildings can simply stop that. Right, the waves could not travel. Waves could not travel, right, long distances. But talking about mid wave or mid band, okay, it can still, some of the waves can still cross this buildings and it can reach to some extent. But talking about low band of 5G, right, it can reach very long distance. Even the obstacles are not a problem at all. So something like now you are experiencing 5G, right? But it can reach some long distances. Typically, it follows some technology like beamforming and multiple input, multiple output concepts, right? Massive multiple input, multiple output technology, where you will have more number of transmitters as well as more number of receivers, right? So the antenna structure itself is different. It is having multiple input, multiple output. So the antenna station is providing more directional submission of beams, beamforming, right? So you get a directional transmission and reception. Remember the conventional antennas, what you see in 4G and so on. We cannot have this, more beamforming. All right. They also have multiple input, multiple output antennas, but not as massive multiple input, multiple output, which you can see in 5G technologies. There is also a concept of network slicing, because the 5G is trying to provide end-to-end network. Okay, so for example, the sensors connected to some communication nodes, okay, some connection nodes, and then it is performing the action, right? So when you talk about the networks with 5G, you are able to provide the functions, network functions, that really create the direct experience, right? Logical end-to-end connections, because It has this software-defined network approach as well as some virtualization, network function virtualization, which is the core concept that follows cloud. Okay, virtualization, cloud virtualization. In typically in other normal clouds, we only talk about virtualization in compute nodes, right? Compute virtualization. If you talk about EC2 instances, right? They are all compute instances, compute virtualization concepts. Storage virtualization was also there. No, storage virtualization was also there. Now we are talking about network virtualization. Okay, so network virtualization basically with network function virtualization. So many like routing functions or switching functions, they are all virtualized, and all these virtualized instances are created with the help of software-defined approaches. So you really experience a kind of slicing, okay, network slicing for different individual applications, right? Right from the accessing radio access networks to the core networks and directly to the cloud and so on. So depending on the slices, okay, it is classified into certain types like enhanced mobile broadband slice, massive machine type communication slice, ultra reliable low latency communication slice, vehicular to vehicular communication slices, high performance machine type communication slices. So the definitions for these slices differ. Like for example, think about massive machine type communication slice. This is mostly focusing on IoT based systems. Okay, 5G for IoT. What is difference in IoT based systems are now? These kind of networks, 5G networks, should support massive number of devices, right? But think about this mobile broadband type of slicing. Here, you are not focused on more number of devices, but you are focused on creating a very good broadband connectivity to all connected devices. So the requirements differ, the functionality differ, and accordingly the network could be designed, right? The slices could be designed programmatically, and that is possible with the help of this 5G technology. So people have also developed some convergence maps, like where and all 5G connectivity is available. 6G networks is slightly ambitious ones with even more higher speed and even lesser latency, but it is not available at the moment. It is under research. It is expected that it could arrive in the period of like 2030s. So here you can expect more virtual reality, right? Like people are talking about metaverse and so on, like creating avatars, right? So you can place your glass, and with the help of this 6G connectivity, you are expecting that you get seamless speed, right? Even in your outdoors, right? You could ask, can't we do it with Wi-Fi, right? You can do it with Wi-Fi also. Wi-Fi also you can expect a very high speed, like 10 gigabit per second speed is also there, but they are not licensed ones, right? So we talked about 5G, 6G. Now we are going to discuss how this 5G, 6G will help in remote healthcare monitoring. So remote healthcare monitoring basically is one of the application where you can think about 5G systems, right? Healthcare application is very important application and upcoming important application, right? Remotely You are going to monitor, and remotely you are going to control the health status of patients. Of course, it became very, very, it took a step ahead when COVID-19 was in place, right? Because patients could not go to hospital, and you cannot do some regular checkup. And at that time, this remote monitoring became more popular, right? Remote monitoring and control of such things, right? So I was talking about some system like sensor and actuators. So here in remote healthcare system, you can expect some sensors, right? And they are connected to the computational nodes. And in addition to computational nodes, you can also see like hospitals and some doctors, right? Patients, experts, and so on are connected. The communication protocol here is 5G, right? 5G systems. Because we are focusing on 5G. You can also connect it with Wi-Fi, but it is limited. It has different protocol. You can also connect it with LoRaWAN. The approach may be different. You cannot do um, real-time operations with LoRaWAN. Okay, if you do that, then you will not complete the operation. The patient operation will be successful, but the patient will die. Right. So typically, sensors actuators will have the direct connections. You can see like in-body devices are there, on-body devices are there in such healthcare, remote monitoring healthcare systems. For example, some sensors like neurostimulators, like they are sensor and actuators put together in body, inside body. Cardiac defibrillators, insulin pumps, like cochlear stimulators, they're all serving different purposes. On-body devices like wristwatches, dresses, dress also you can have some sensors, rings, adorable devices, pedometers, and so on. Portable devices. You can have static devices as well as ambulatory devices. Like for example, the devices that are mounted on hospitals to check air pollution, for example. Ambulatory devices are devices that keep moving here and there. Obviously, 5G will be a very suitable communication system here because you cannot expect Wi-Fi everywhere, right? So ambulatory devices will definitely need a very high-speed network, and systems like 5G, 6G connection protocols will fit very well here. Hospital devices also may need, will have some sensors. Like for example, uh, patient patients sometimes want medical equipment such as defibrillators, and hospitals will have some information about that. Some of the health monitoring sensors like camera sensors, temperature sensors, heart electromyography sensors, V's anomaly detection sensors, movement disorder checks, stress detectors. Remember, all these sensors, posture indicator or lung status indicators, these are all specifically for health monitoring. Okay, so in such health monitoring systems, you can expect a large volume of data, just streaming of data. For example, like think about camera sensors. No, patients, for example, the doctors, 5, 6 doctors sitting together and doing some remote operation with the help of robots. So the sensors from the robots, obviously, most of them will be camera sensors, and they have to feed the data to the doctors. And the doctors, with the help of this virtual reality system and so on, have to make the operation. Right? So in that case, 5G is an important candidate to connect all these systems, right? Traditionally, cloud only was there, but nowadays I'm going to say that cloud alone will not be a very successful one. right? Say, for example, in a remote healthcare monitoring system, if a robot is performing, let me place a robot like this. Robot is having a lot of sensors, camera sensors, right? Some actuators and so on. If these camera sensors are sending all the data to the cloud, the network bandwidth, even though if it is 5G, if it is having high speed, still it is not a good approach. Okay. First of all, privacy is one of the concern, right? And second thing is cost ineffectiveness, right? If you are doing all computations in cloud, you will have to pay everything to cloud compute, right? You will have to pay most of the scalable devices in cloud, and you will also pay for storage and computation. Instead, edge-based intelligence, right? 5G connection should be there, but intelligence-wise, you should not only utilize cloud, you should also utilize edge. So edge means near to the robot, right? Near to the robot, you should have some computation. Okay, some computation. And this computation, sensors will connect to the computational unit here in the edge using 5G, and the computation should be fast enough to make some decisions and provide the decisions back to some actuators, which is also placed in this robot. Obviously, you are reducing the network bandwidth, the entire network bandwidth that connects between the edge device and the cloud device, right? So the response time will be even fast. So this kind of communications or this kind of setup is typically termed as next generation IoT, right? And also you increase the security and privacy. So if you think about this healthcare monitoring system, based on what type of computing system you use, we can classify them. Based on what kind of intelligence you perform, whether you are uh, here, whether you are performing the intelligence as a descriptive one or diagnostic one, discovery one, predictive one, or prescriptive one. So the level of intelligence also differs, right? So the connectivity is assisting you to create the different levels of intelligence in such applications. Depending on what kind of communication that you use. You can use Wi-Fi. You cannot use LoRa in many of the cases, but still for some applications you can think about that. But definitely for remote monitoring, healthcare monitoring, especially when you think about mobile, the camera, camera kind of sensors, LoRa will not fit very well. But Wi-Fi is one of the candidate which you can think about in some cases. 5G is definitely a good candidate for remote healthcare monitoring applications. So depending on what kind of communication you use, you can classify them. Depending on whether you are going for local connectivity or global connectivity, you can classify them. So here I'm going to talk very important concept in 5Gs. Okay, you yourself can create a network, as like how you create Wi-Fi. Okay, you can create Wi-Fi for your organization on a particular lab. As like that, you can also create a private network with the help of mobile systems. Okay, with the help of when I say mobile systems, it is no circuitry systems, right? Telephone kind of circuitry systems. You can create 5G networks. Obviously, these kind of private networks are well suited for remote monitoring, remote patient monitoring in hospitals, remote operations, intelligent solutions, and so on. So let us see what is this private networks. So this means no, you are creating a separate private network, but with the help of cellular technology, right? Not the data kind of technology as like you see in Wi-Fi, but it is cellular technology. But setting up the network and the tower, because normally when you talk about network, you will have a tower and then you will have a lot of devices, like mobile phones. Mobile phones will have SIM cards, SIM cards. So even your laptop, if it has a SIM card, it can connect to such mobile networks, right? So uh, if you want to create a private network, especially in industries or some hospitals for remote connections in a in a smart city, okay, where doctors may be staying somewhere at home, right? Maybe it's very late night, but they don't want to rush to the hospital, or he is stuck in a traffic jam, but he can give the advice while he is traveling, or he can perform some operation while he is traveling, right? So all these are possible with the help of this 5G private networks. The private network is deployed in two models basically. One is standalone deployment, and the second one is non-standalone deployment. Standalone means a separate 5G network with dedicated equipment, and the network functions will be set up purely for 5G alone. Okay, it is not combined with 4G or LTE or nothing. Okay, it is not compatible, or I mean, it will be compatible, but it is not designed for that. Non-standalone means it will still utilize the infrastructure or the existing infrastructure like 4G networks. So, for example, BSNL will have a 4G network, and from that 4G network, some modifications are added to create 5G. Then it is not a standalone deployment, right? So, standalone deployment is currently offered according to the literatures. We can see that it is offered in the US by the provider called Nokia. But most of the existing 5G deployments are based on non-standalone deployment models. AWS, a cloud platform, if you could recollect what I told in the first slides, IoT came from the background of cloud, right? Clouds providers and cloud setups, right? So they are also offering this 5G networks, 5G private networks. So 5G is also offered by AWS. Just it is simplifying the purchase and the deployment. Okay, as like how you set up a Wi-Fi system, you can also set up a normal 5G with the help of AWS installations. Is it difficult to set up such 5G network? Because you may need to integrate many of the devices. You may need to handle the authentication and authorization if you are doing it by yourself. You may need to create some sort of pricing models or auditing models, because everyone should not use your network. You may need to scale the services, right? Uh, in fact, AWS or existing cloud setup is already having many of these components, right? Say, for example, authentication authorization is already there. AWS already has a lot of products for authentication authorization. It also has a lot of pricing schemes, budgeting schemes, already existing services in AWS. So you can simply integrate them. For scaling also, for example, you need a lot of computation. You need kind of scaling services. Auto scales products could be used. So it is not like you are developing everything from scratch. If you go for existing setup, you can, like AWS, you can simply utilize those services. You can integrate them. Steps are very simple. You have to just log into the console. You have to get the you have to order that equipment because you need a small tower, right? You have to install them, activate the device. Then on, you can start to manage the resource as well as scale the resources, right? So what all things you get if you order? You will get a small cell radio unit, a small tower, okay, small tower. Because I have told there are 3 bands. If it is no, if it is high band, sorry, if it's a high band, um, uh, obviously the range coverage will be less, right? If it is mid band, okay, the coverage will be even little higher. If it is low band, it will reach long distance. I have talked about this area, right? When you plan to establish this private network with the AWS, you will be provided with a small cell radio unit, one network core software, radio access software, and the SIM cards. So with the SIM cards, you can connect all devices, say sensors connected to some small microcontrollers or small Raspberry Pi modules, or some extra module that you add for SIM cards. Then this becomes a 5G enabled device. This 5G enabled device is connected to this radio station, right? So like this, every radio station and actuators and sensors could be connected. And you now create a private network, okay? As like how you connect a wireless access point and make a private network of your choice, right? You can do that with the help of 5G. In a autonomous vehicle system, imagine you are a autonomous, some car manufacturer, as like Tesla, right? You can create a hub of 5G networks. Here one 5G network, here one 5G network, here one 5G network, and so on, right? This is the road. The vehicle moves here and there, like autonomous vehicles are here. Since they are all private network or belonging to your own company, you can set up this private network and you can support all these autonomous vehicles, right? The handoff will be very fast. The speed will be very fast. Bandwidth is also very fast, right? So this is how you can create. And the unfortunately, it is not available in India. Okay, it is only provided in the US at the moment. So you can expect that within 3-4 years, you will find such setup in India also. It is, yeah, I would like to compare this 5G with Wi-Fi. Remember, Wi-Fi will be cheaper. Okay, you don't want a tower. No, you only need access point. So Wi-Fi will be cheaper. But installing Wi-Fi on roadways or something is not, no, it's not practiced. Okay, it is not practiced because 5G is not a, sorry, 4G is not a licensed one. Anyone can get connected, and then you may, even in your laptop, your organizations, you may notice, if you find a Wi-Fi, you can simply connect it, and license is not really needed. So it is not a candidate communication protocol for many of the applications, including remote healthcare monitoring applications. So 5G could sometimes fill this gap. Of course, you can add some authentication, authorization, and so on with Wi-Fi. Speed-wise, also Wi-Fi is good. Range coverage is somewhat limited. Obviously, always limited with Wi-Fi, but with 5G, you can still extend it with the help of different bands. Low band, with the help of low band, you can still reach long distances, and with the help of beamforming and so on. But Wi-Fi people, Wi-Fi alliance groups are also trying to find compatible ways to compete with 5G. So what you can see here is in most of these applications, intelligence plays the major role. Sensors, right? Actuators are here, and in between some connected nodes are here. They are all connected. Assume they are connected with 5G. Let us take connected vehicles, autonomous vehicles, or remote monitoring, healthcare monitoring systems. Everywhere, intelligence is important. Some sort of inferencing is important. Learning is important, right? So learning is done using some algorithms, right? You need to sense the data. You need to perform some intelligence. Connections are through 5G, right? And you need to perform some intelligence. Deep learning is one of the approach, or deep learning is one learning algorithm, which is similar to machine learning, but with more in-depth knowledge, right? Machine learning, from the name itself, you can understand machines are learning, right? It's a subset of AI, and you can see deep learning is where you will have more hidden layers to learn lot of features for several times and so on, and do the computations. Why we need to understand this deep learning models here is, I'm saying that computations are involved here, right? So many computations are involved here. Earlier, the deep learning algorithms are computed only on one machine, right? Sensor is sensing the data. Some intelligence is happening here with some connected devices. All connections are happening through 5G, right? But people didn't think about splitting the workload to multiple devices. Why? Because the all these connected devices that needs to perform intelligence are not showing a good latency, right? Expected latency. If you are able to provide a better latency, I mean improved latency, right? As like how 5G could do, then some processing could happen in one computational node. Then with the help of 5G, you transfer the data to the another one. Then you can get another layer of computation here, another layer of computation in the other computation node, and so on. So the hidden layers keeps sending the computing, sending the data, computing, sending the data, and so on with the help of 5G, because the speed will be very high. In most of the remote healthcare monitoring systems, I have told that camera sensors are involved, which means you are falling under this computer vision problem, right? Computer vision, which means you are assessing and doing some image processing or image related step, right? So there are several algorithms for that. One among is convolutional neural networks. The other algorithms are like YOLO. Different sensors, right? Getting the input, then calculating the weights, and you are finding or inferring what will happen, right? As like in single perceptron or your neurons, how it functions. Each neuron, how it functions. In a single neuron, typically, as a human being, you get the input from so many sensors like eyes, nose, ears, and so on, so on. Make a weight, create a summation, and decide that whether it is whether your food is biryani or something, right? You are seeing that okay, it is biryani, so that's one input. Smell, you can touch. All these inputs put together with some different weights, and finally you say that it is biryani, right? Your neuron is acting accordingly. So like you're resembling the concept of that. Convolutional neural networks is very popular algorithm, learning algorithm under this deep learning concept. YOLO, ResNet, so on, so on. There are so many algorithms. Okay, I have listed many of those algorithms in this particular book. I would recommend you to read that if possible. Also, sentiment analysis kind of applications, right? Uh, Even in remote healthcare monitoring application itself, you can think of such applications. Autoencoders, it's again one kind of deep learning technique that applies data encoding methods, right? Data encoding methods to converge or bring down the uh, input features, so that uh, you can store that efficiently and send that messages efficiently. So, for example, the camera sensors are sensing, right? Cameras are sensing, and then you can apply such auto encoders to capture the frames and bring down the frames, the features down to some encoding method, right? Compressed form. So that you effectively save the network bandwidth before you do some sort of learning processes. Typical applications like image reconstruction, image colorization, image generation, right? Also some GAN applications. All applications, there are a variety of applications you can think of. These are all different algorithms. The core topic of how I have explained this lecture basically is, you have sensors, right? They are all connected with the help of 5G, assuming that we are connected with 5G. In the connected devices, where you want to perform some intelligence. These intelligence, when you perform some intelligence, you should run some algorithm, right? Using some computational nodes, either in cloud or edge or fog, or no. If it is very near to the sensor node, we call it as edge. If it is a little far away with a slightly powerful one, then we call it as fog. If it is a centralized one with highly scalable compute nodes, we call it as clouds, right? When you perform the intelligence, when you perform such set of algorithms, some portion will be computed here, and then you can transfer it to some other compute nodes. Then you can transfer it to some other compute nodes, and all these communications could even happen through 5G networks, right? You can also have some reinforcement learning algorithms, right? Agent-based or reward-based approaches. Um, More commonly, when you think about autonomous driving or healthcare or gaming sector, obviously 5G can play a major role when communicating between the devices. So typically, there are some uh, you know, packages or software frameworks that help you to develop such intelligent systems. Deep learning can use TensorFlow or PyTorch frameworks. If you want to perform this uh, intelligence very near to the sensor nodes, which means no in the edge devices, you cannot use the entire operations or deep learning algorithms that you can do it on powerful machines like cloud. So therefore, you may need a smaller version of ML, which is called as tiny ML. So this is a subfield of ML, again in deep learning also, okay, which tries to minimize the versions of what you can do with cloud. AWS also has similar features, okay. When you talk about the networks, you need 5G networks. When you talk about computations for performing intelligence, you may need some mini versions of ML so that it fits to the edge-based devices, which is typically like tiny ML. You can get more insights in the textbook which I have recently written. There are so many embedded devices which can support them. Some devices like Jetson Nano or expressive processors could do that, right? When you think about edge learning, you can opt for federated learning, gossip learning, or transfer learning. Many people perform transfer learning. Federated learning means it's kind of collaborative learning approach. It's a kind of master worker approach. Like the computational nodes are doing some learning process where one act as master and the others are working as slaves or workers to understand or to infer what comes out of all these camera nodes, right? That is federated learning. Gossip learning is something like a decentralized approach of learning, still applied in deep learning concepts also while performing intelligences. It aims at reducing the modeling time. Basically, for example, you need to apply gradient descent search in parallel while creating the model. Transfer learning is also very commonly used, where you learn something in one context, but you apply that to some other context. For example, you learn apples from the learned models of fruits, but you will apply it for inferring mangoes or something like that. So that is kind of transfer learning. This can give you a quick learning inferencing or quick learning, but there are some improvement methods because there are performance issues there. You can improve them by providing techniques like edge caching, compression, offloading, inferencing, placing the services properly, and DNN splitting. I talked about DNN splitting in remote healthcare monitoring slides, right? Where you will have sensors, right, cameras, and some computation should happen in the computational nodes, such a way that some layers function here, right? For example, if you are applying some deep learning neural network here, you perform some computation. Like one layer you do it in one computational node, another layer you do it in another computational node, another layer you do it in another computational node. In between them, the communications will happen through 5G networks because you need high-speed networks, right? So this kind of intelligence could be done, right? And that is termed as DNN splitting. Caching is like you cache whatever you think that it will be useful later. Also, then you cache that content, right? So, for example, in remote healthcare monitoring, if you are if the robot is aware that this is how the images will look like among 100 frames, if 80 frames are going to be the same, then it can cache all these 80 frames right near to the edge itself. Of course, because of this, it can be faster, right? You save network bandwidth. Where do you want to cache and how do you cache? This is dependent on one aspect of research. You can compress models. One approach, what I told, like applying autoencoders or some other methods. You can play around there to improve the accuracy and still reduce the compressions. In terms of DNNs, you can prune DNNs. Okay, you can reduce the number of weights between the neurons, so that itself reduces the uh, uh, learning processes between the neural networks. I told that TinyML will be helpful in edge devices. TensorFlow Lite provides that. Okay, TensorFlow Lite is supported in many of the edge-based devices like Jetson Nano, Coral AI, or ESP32, SparkFun boards, and so on. Some of the steps to create the TF lights are shown here. Like you can create the TF lights and you can copy the TF light to such embedded devices, right? And thus you need not recreate the learning steps once again. There are also some tools that are offered by Google to create such TF lights. You can create TF lights using such tools, and you can offload that to the edge devices. They are supporting audio samples, image samples, and human poses. But how it can be done is shown here. Right? You can create classes. You can upload the images, and you can label them automatically. It will be labeled automatically, and you can create the models. And these models can be then transported to edge-based devices. Depending on what kind of edge device you need, you can create the TF lights. So far what we have seen now, we have talked about IoT, next generation IoT systems, right? We talked about different protocols that are used for connections. I haven't talked about the service level protocols, but I have talked about communication level protocols. So many protocols we have discussed. One among protocol or one among communication standard is 5G 6G. We discussed the advantages of 5G 6G and we also explained that with the help of an example called remote healthcare monitoring, how 5G will help in such systems. And I told that when you apply intelligence on the connected devices, right, in IoT-based systems, in the connected devices, you can use deep learning, and deep learning can be transported to nearer to edge also, which we call it as edge intelligence, and how the inferences or how the learning processes are transferred from one node to the other node in such networked system was also discussed. Obviously, 5G will play a major role. Now we are going to cover a very brief research directions in 5G. So one kind of direction which you can see in such systems, to create some architectures, right? IoT, edge, and cloud architectures that support 5G. When it supports 5G, you could try to design the architecture that optimizes them. Okay, you can fully provide 5G networks, but that is not going to give you a better resource, right? You want to optimize the networks. So that is one research domain. The second research domain which you can see in this IoT 5G field is you apply deep learning to organize the networks, right? For example, you take a autonomous vehicle system. You have so many 5G antennas, okay, 5G stations, right? These vehicles should move here and there, right? So how these networks can organize themselves, right? Such that you create a proper network slice. A proper network slice. You can even write some intelligent algorithms, deep learning algorithms, to create such better network functions that will create self-organizing networks. Say, for example, a handoff should happen between these two networks when the car moves from this place to this place, right? So that is one simple example how you can do. But this is very naive example, but you can think of some complicated examples. Another research direction is allocating resources. right? Resource allocation. You can apply AI approaches like reinforcement learning approaches to optimize the resources by allocating resources properly. You can think about distributed learning. I have talked about transfer learning and some other federated learning concepts. So that this, when you talk about distributed learning in such 5G networks, algorithms and architectures will change. That is one of the topic which people work on. Obviously, tens of thousands of applications could be taught in different domains like smart cities, industries, agriculture field or healthcare or supply chain management and so on. Novel applications could be thought about, right? Which might not be covered in many of the literatures. So that itself is one kind of research direction. You can think about developing a new learning algorithm. Okay, you can write a new learning algorithm, basically, um, which create very robust learning approaches. And also, security is another very important topic of research, which I haven't covered in this discussion. Right. So these are some of the research directions that you can think about. I would like to provide some announcements before I wind up this session and hand it to the organizers. So the some of the discussions or announcements are: we have MSME incubation centers, right? Atal Incubation Center. Typically, for each business ideas, we provide like 15 lakhs for MSME. And with the AIC Incubation Center, we support a lot of startups as well as ideas. If your students have developed a company or are willing to develop a company, our incubation center could support for that. And there are a lot of provisions where you can get like 1 crore or some funding. We ourselves can provide up to 50 lakhs through seed fund money. So this means a successful idea and a student has developed a company and it's a good idea. Based on the shortlisting processes, you can get funding to start or develop such kind of systems. We also invite nodal centers. So our this particular Section 8 company can act as the hub where your engineering colleges could act as nodal centers to support us. There are some procedures. Every year, twice we call for nodal centers. And we also invite joint hackathons, consultancy works, joint editorial, and so on. So I would highly recommend you to look into this textbook, which will be of useful for some of the people who think of developing deep learning algorithms for their societal products with IoT in your mind. So anyway, thanks for your patient listening. And I am now handing the session to the organizers. And once again, let me thank the organizers, right? Kavya Madam was in touch, as well as Dr. David sir was also in touch for this particular talk. Okay, thank you so much, and the dice is with you.
So thank you so much. One small correction. My name is Kanmani, not Kavya.
Sorry,
But,
yeah, sorry. Yeah.
no problem, sir. Sir, really, the lecture was very useful. It was given in a well-structured manner. You started with next generation IoT, then you covered all the trends in IoT, then protocols, introduced to 5G, 6G networks, and you connected this IoT with 5G. and also the intelligence, how it can be incorporated, and finally you end up with research directions. And this is what we expected in this lecture today, sir. And I am sure all the participants would have been benefited. And for the research scholars, it would have been a very useful thing, because nowadays all the research scholars are finding difficult to identify the research areas. So I hope this lecture would be very helpful, and also for the faculty like us, it has given a good eye opening on how to connect this 5G 6G with IoT, because IoT is also trending and 5G 6G individually
Yeah.
people will be knowing, but then connecting both is a very beautiful concept. You made it very simple, clear, and it was very good. Even in this late evening, in this tired mood, we felt very useful. Thank you so much. And without even taking a small break, you have given this lecture. I thank wholeheartedly to you for accepting our invitation and spending time with us. Thank you so much. I request you to hold on for 1 minute. We'll take a photograph
Yeah.
for a screenshot. I request all the
Okay.
participants to switch on your cameras so that I can take one photograph. Please, participants, switch on your cameras. Actually, in many places, the climate condition is not good, sir. So there are a lot of network issues also.
Okay.
Yeah. Please hold on for 1 more minute. Please, participants,
Sure, sure.
kindly switch on your cameras. Okay, thank you so much, sir, for spending your valuable time with us. We do connect with you as you have given that last introduction to your incubation center. We wish to connect with you. And in future, I hope not only me, all the participants from many colleges have also participated. It will be an awareness to them. We'll connect with you. We'll work together in future also. Thank you so
Yeah.
much. Thank you,
Thank you.
participants.
Thank you.
Yes. The participants shall leave the meeting. Thank you. We will meet tomorrow by the same time. And tomorrow, Shantana Krishnan sir from BSNL will be giving the lecture. So I request all the participants to log on 5 minutes earlier at 6:55 and be ready for tomorrow's session. Thank you, all of you.